I we are now officially live. So this is our July community update for 2023, and today I have Heard here with me. Hey Guy,
Hi.
really appreciate you joining me today.
Yeah, thanks for having me, Bailey. It's great to be able to give an update on some of the work. So
Yeah, we've got a bunch of different things that we can talk around. I think the one that I'm most excited about is WASI-Vert. Do you mind giving an overview of what WASI-Vert is?
sure, I suppose we're speaking to an audience that's fairly familiar with the WebAssembly and WebAssembly component model. So WASI-Vert is a project which very much builds on the strengths of some of these primitives in enabling sort of context-free linking and having first-class sort of imported capabilities through WASI. So WASI-Vert is an attempt to it's a new Bytecode Alliance project that provides virtualizations of these WASI interfaces. And I guess the simplest example to think of for this is if you're writing a traditional application, you're going to be typically depending on all these POSIX level primitives and wrapping that up in a way that can work in different environments or providing different levels of access to it. So virtualizing these sort of WASI primitives and having different types of virtualizations that you can describe. And I know you also had some examples of things that you had cases where you were virtualizing file systems and things like that, where we can even mount the file system itself inside of the virtualization layer. So you can have virtual file systems and built on top of the primitive. So as opposed to it being some kind of special kind of add-on, it builds directly on top of the component model. So yeah, it's something that is very clear once you get a picture of how the component model works together with its first class virtualization. But that's the key thing, really, that we have first class virtualization in this component model. So by plugging into the existing virtualization, the component that you get has the WASI virtualizer inside of it and the main component, and then you have a singular component that can be bundled together with its virtualization. I don't know if that was a very good explanation, perhaps not,
That's great.
but we can certainly go into it in some more detail.
Yeah, it was great. I think it's important to highlight too that this concept isn't entirely new to the component model, although this is a component native implementation. I would say I remember virtualizing file system stuff with
Mhm.
WebAssembly with Scriptin a bajillion years ago. I don't know, 2014-ish time frame, and that was helpful. And so what we mean there is that we have an in-memory thing that looks like a file system and acts like a file system, but maybe isn't necessarily a file system. Maybe it's backed by something wholly different. Could be the IndexedDB, for example, in a browser. And so the idea isn't totally new. And what got us talking about the need for this type of project was Yato Saito, who's behind WASI VFS, reached out and kind of talked about wanting to maybe find a way to make component native implementation here. And we discussed, and Guy kind of made a proposal here that walked through. And you've been heads down on it for, I would say, mainly this month and just this month. So it's a brand new thing, right?
Yeah, and what's been fun about it actually is that often working on WebAssembly and component model things, you're often working through these very complex details, or I typically work on JS tooling as well, and it's all quite sort of low level. And virtualization is certainly low level, but it's been great to be able to uh, be working on top of the system and what's possible to do with the system and things. When you have neat abstractions to work with, it makes it a lot of fun. Yeah, I guess the best way to just describe the virtualization approach is the the context-free linking of WASI. So the preview to WASI is built in such a way that all of these functions are virtualizable from the start, so that you don't have to pick up on all this different context and carefully work out how to weave together, address spaces and things like that. They're very designed for first-class virtualization to begin with, so you can just wrap these things together. And when creating virtualizations, you can actually treat the virtualization as its own WebAssembly component. So you can create a virtualization component, and that virtualization component, instead of normally when you create a WebAssembly component, you'd import all your APIs, like your file system APIs and things like that. With virtualization, you export those same APIs. So you're turning it around. And then when you add the virtualization, that's a composition of your application with the virtualization component. So it's a kind of a first-class component linking, and the component that you create is then a composed component. So it's combining those two, matching the imports to exports, and then the final component has no imported APIs. So it can be fully virtualized. It doesn't need to run in an environment that has first-class WASI support. It can run in a browser or somewhere else where it's entirely running on virtual POSIX. And it's just through that natural composition of components, you get this one component which combines everything together. And so yeah, at the moment we just do file system and environment. So it's a very simple start. But that's probably a good 50% of the use cases, and then we can potentially look at other virtualizations. It would be great to get sockets support as well, which would be really fun to see what we can do with that. But it's really nice to see the potential when you can just very easily mount virtual files. You sort of build an app, mount a file system, set up some environment variables, and all of that can be turned into a new component. So you sort of can work through quite easily.
I pulled this
and then, as you
diagram
say,
up because it kind of describes what you're talking through, right? You've got one WASM component. It might have multiple component instances that was composed together with other components. One needs a WASI file system, for example. Another one fulfills that import by having an export. And then the final thing at the top level is that a host to run this component doesn't have to give you a file system or a WASI file system. So sometimes diagrams help folks, so I try to throw those on there. I know that the next step we're going to talk through is some of the things that we can do with WASM Tools Compose, where we can take multiple components and make one component out of it. So I'm going to jump back to your README here. Sorry to interrupt.
The diagrams are great, and it is a very visual process, and actually it's best to sort of see it visually, because it is a very direct kind of, you're matching up these imports and exports in the graph, and that's the picture you want to have in your head of what's going on. But yeah, if it would help to illustrate a bit further, I can always show you a very brief kind of demo of how this kind of stuff works, and maybe that helps a bit more than just talking about it as well.
That would be fantastic. I love a demo.
Okay.
We can go off a README all day, but demos, they're gold.
As long as they work, but hopefully we'll be in luck today. Let me see if I can get the screen share going.
Yeah, and while you're pulling that out, I'm going to give a shout out to wasmbuilder.app. This is a tool created by Peter Heun, and you and he both showed this off at WASM Day at KubeCon EU, showing the future of component tooling was the talk. And I really love it because it really does give you a visualization of composing your app together using the same tools that the CLI uses. I'm posting that in the chat now. Cool. All right. So I see your demo. Do you mind making the font like massive?
Sure.
Yeah, there it is.
Okay, so imagine the basic case of you're building an application. In this case, this is how you write this is one of the ways to write a Rust component. So this is a simple Rust application. And we've got this sort of bindgen macro here, which is building it as a WebAssembly component. So I've got the build step kind of set up. that'll output this test component.wasm, and that's a WebAssembly component file for this Rust application. The components are defined using WIT files. So that would be this WIT file that's being loaded. And in here you can see it's defining it's this test app package. And then it defines its world, which allows it to define the imports and exports of that component that we're building. So in this case, we're importing all of the WASI APIs. So that's everything necessary to kind of replicate the sort of standard sort of capabilities that you get from clocks to sockets to file system, environment variables, standard IO, etc. And then I've just added a simple test function here. And this is just a function that takes an input string and returns a string. And that's the function that I'm writing over here in Rust. So the base case is I just have the function, I take the string and I return the same string. So when I initially build this, what I'm getting is something that's going to just echo its own output to that test call. And then I've got a running application which will load this component, run the test call with the argument I provide. So I can run that here. I've just called it test app itself, and I can run it against that test component WASM file that I just built, that WASM component. And then the argument I'm going to provide, which is this path string, I'm just going to sort of echo. You can see I'm inputting echo and I'm getting the echo out. So this is just an example of how you'd like write a WebAssembly component normally. And then the question is, what happens when you start using, Rust standard APIs that are accessing the file system and the environment variables. So let's uncomment the second line. And in this case, instead of just echoing the path, I'm going to use the path to read an environment variable or return no path if there's if that environment variable doesn't exist. And the default for that, if I then build this component, is I can sort of get my path, and I've got all access to all of this kind of OS level access. So this is obviously not the right level of capability access that you typically want. So this is where WASI-virt comes in. So I say, well, what if I still want to have the ability to read environment variables, but I want to virtualize it so that I provide the environment variables. I don't want to just provide host level environment variable access, but I don't want the person running my component to have to think about environment variables. I don't want to send them a whole bunch of instructions and say, oh, when you run this, you have to set up these environment variables. You have to set this, in the file system. I want to just wrap all that up with my application. So we've got this WASI-virt command, and I can provide some options to create the virtualization. So in this case, say I want to set an environment variable, and I say the path is going to just be, let's just make it a empty string. And what that'll do, actually, I don't have empty string support. I should add that. Let's just make it anything for now. And in this case, I'm now setting that environment variable. And when I output the virt WASM, it'll give me the virtualization component. So this is that component that now, instead of like our normal app, which imported all the WASI APIs, it's going to export all the WASI APIs. And you can even check that with WASM tools component WIT. If you look at this virt.wasm, you can see it's exporting WASI APIs that it can then compose with. So instead of creating the virt component, well, actually, what I'm going to do is then use WASM tools compose to compose that virt component with my application, which was test component.wasm. And I'm going to use the D flag so that the definitions of the imports come from this virt.wasm. And then we're going to output that to test component.virt.wasm. So that's worked. The warnings are just because it didn't virtualize everything. It just virtualized the environment. But that's now created this test component.virt.wasm, so we can then run that again. And again, we're going to pass the path variable that we want to read, but this time it's got the virtualized output. So it's fully virtualized the environment, and that was all done as a kind of a wrapper step. So I could take any component and now compose it with the same virtualization, and it'll get that same environment. If I try to access any other environment variable, it's not going to work because it's fully encapsulated all the environment variables. If I did still actually want to provide some environment variables, there's also like an option to sort of say env allow, and in that case, it'll still fall through. And if I add the component into WASI-Vert, it'll do the WASM tools compose step for me so that I don't have to just keep retyping that. And let's make that component.vert.wasm. WASI-Vert allow end, sorry, not end, allow. And now I should have access to home. Allow env equals home. Well, the demos don't always work first time, but there's probably something silly I'm doing there. I don't know if you can see what it is, Bailey.
Yeah, do you mind hitting enter a few times? Let me see. Our heads are in the way is my problem. Okay.
All right. Yeah, so I think that's WASI-Vert test component.wasm, and then I'm setting my path. Yeah, well, I'll check that one later, but that's supposed to be a pass-through mode. I don't know why that's not working right now. That's probably a bug to fix. And so yeah, that's environment level virtualization. To just take it to the file system, if we still have time, very briefly, I can update that same example to instead of reading an environment variable, read a local file path and return the contents as a string. So when I now run this test app, test component.wasm, and then the argument that I'm going to pass is going to be the path to load. So if I load from users stupid bird projects WASI-Vert test app, I can actually just print the WIT file that we have for test app. And this is running against the local operating system, so that's unvirtualized. And if I want to virtualize this with WASI-Vert, I can say mount, let's mount our WIT folder from the local WIT folder. And then we're going to output that as fs.vert.wasm. And that should do the mounting. So that's gone through and virtualized all the files into the virtual component. So it's actually gone and globbed the entire WIT folder, turned that all into a virtual file system inside of this new virtual component. We can use WASM tools compose to compose our test component with the definitions from this fs.vert.wasm. And that'll give us this new component, test component.vert.wasm, which now has the virtualized file system. And if we run the same test against that, we now have this mounted WIT folder, and it doesn't need to have access to our entire file system anymore. So with some luck, that should work. Yeah, and then you can see it's running entirely from the virtualized file system, and this would work in any other environment without file system access now. So like a browser or anywhere else you want to run your components without having to go down to the actual OS. And there's also, again, the option, I won't test my luck on it now, given that it didn't work for environment variables, but there is also the option to pass through still to have some of the mounts coming from the host file system. So you can kind of have custom virtualizations that way as well. Yeah, and that's pretty much it. So I'm happy to answer any questions you have on that further as well.
Yeah, that was fantastic. I think you highlighted some of the key reasons why somebody would do this. And I just want to make sure we make that like really clear is not having to give a file system is so important for host operators. So one of the reasons why I was instigating for wanting something like WASI-Vert was that I work on a project that embeds WASM time, and other people run and host it, right? And I want them to be able to use WASI because hitting the standardized APIs and having support for standardized APIs means that apps can be portable onto my system. So that is a big goal for me. But it's kind of hard sometimes to provide a sandbox without doing a lot of extra work, like making sure that I have something that handles running out of system resources. Like somebody set something up for a log and it just goes forever if I'm not careful about making sure I roll my logs. That's one easy way to cause issues. Sandboxing a file system is really important. So there's so many different solutions out there like MinIO and, well, just so many. I'm not going to get into the container world here, but I will say that it's really important to people who are creating these WebAssembly runtimes and creating the platforms around them to be able to say, yes, I still have a sandbox and it's safe, fast, and all of the key properties that we have with WebAssembly, and still portable, right? And so this is one of those key tools in a platform's toolbox to be able to support this. Is there any more you would add there?
Yeah, I think that's, I mean, the fact that you can also do it in a, as you say, in a way that's portable and in a way that kind of captures the full interface, because this is one of those things where it normally, there's all of these sort of edge cases to this kind of stuff, and catching all of the different edge cases is tricky. But because we have such a well-defined, execution model for components, this stuff all kind of abstracts so neatly in the component model, where it's very easy to reason about what you wouldn't normally think about taking an executable app and like easily remapping it to an application that has, different semantics running on different virtualization layers. You need a full container to do that. Whereas here we can actually do the sort of virtualization at the binary level, because it's a binary format that supports this first class virtualization. And I think it's a really interesting thing to explore and figure out what patterns we want to explore with it. So would love to hear more about like use cases that people are looking to achieve with these kinds of things, and see what we can do to better support them. This is very much a very simple start prototype of the kind of potential, but the techniques that we put together here, the tools and processes that we're using, they can be applied very widely to different types of virtualization scenarios. So if you wanted to, map your file system to another type of API, as you said earlier, IndexedDB in the browser or something, all of that you can kind of rewrap it in terms of any other API. And, that's, I guess, part of the sort of ideas. And when we were initially discussing this virtualization, I know a lot of what you mentioned as well was these ideas that you can have a wide set of virtualizations and different virtualizations that are useful for different scenarios. And there's a lot to explore there, and I hope we can start to share some of these approaches more widely, and that's my biggest hope for this project at the very least.
Yeah, I'm gonna post in the chat here. There's well, if I can figure it out, let's see. There we go. Luke and I had a chat about some other ways of doing platform layering, which is what I guess virtual platform layering is what Luke coined the term. And it's one of these cool things that we can do with components that we can't easily do with other technologies. My team has been calling the case that you demoed here with WASI-Virt, we've been calling those WASI fills, because you've basically created a component adapter, that adapts an API. It's a very common adapter pattern, but it's specifically because it's a WASI API. And then if you look at it, you're like, oh, that's just a polyfill, right? it's kind of what it is. And you're coming from the JavaScript ecosystem, so you're super familiar with that. And I noticed that we actually got a question in chat that maybe you would be able to speak to. This person is asking if, hey, is there any interest in bringing WinRCG polyfills over to something like Javi? I know you work on JCO guy, but I think, one of the reasons why you're interested in a project like WYSIVERT was, you were like, hey, I need something to help me run this in the browser. And so it's it's like a literal polyfill there, basically, even though it's what I would call a WASI fill. And so do you mind talking through some of the things that you've been thinking about just specifically in like JCO or
Yeah,
Java's use cases?
this covers a wide range of topics, and certainly, the JavaScript work is where I spend most of my time, and that's working on JCO and componentized JS and efforts around JavaScript support for components. The virtualization is a kind of a side quest from that at the moment, but a huge part of the component model stuff, and something that we actually need for JCO itself to get it to run in a browser, because we've got a whole bunch of tools we want to run. We want to use the component model ourselves for this stuff, and to JCO wants to access the file system, to access widths and things like that. So we need virtualization layers to do that, even just so that we can have some nice support for turning Rust code into the web and things like that. So WYSIVERT as the basis of a lot of this work. For the Winter CG, that's it's a whole topic unto itself. The fact that JavaScript is not just a language; it comes bundled with the whole platform, right? So when you're using in JavaScript APIs, there's no such thing as like a main standard library. You have things that are defined in ECMA 262, things that are defined in browsers, and things that are defined in all these environments. And the assumption is that you're going to have some accepted subset of these things, which is now sort of being coined into the Winter CG, which is basically just taking a wide range of all the specs across the different places where JavaScript's used and turning that into a baseline standard of what's sort of expected for JavaScript environments. But it's still something that's very much a work in progress, and something which is changing all the time. So the approach that we take with the componentized JS project is that if you're wanting to run JavaScript inside a component environment, you should be able to customize what APIs you have access to, and you want to have access to all of these Winter CG polyfills, so that you can say, hey, I want to use the fetch API, but I don't necessarily want to make high resolution timers available. And you can pick, again, at the JavaScript level, what APIs you want to make available to users. And so getting together a bunch of the Winter CG polyfills is very much a goal of the componentized JS project, I would say. That's something that we're working on, and something that we're very much hoping to collaborate on as well. So doing that in a way that can work across environments. Javi is a bit trickier to collaborate on because of the fact that it's the polyfills get quite tied to the exact engine, but SpiderMonkey specific built-in sharing, I think, engine specific built-in sharing is the goal for that. And I know that we have also had discussions with the Javi folks about SpiderMonkey built-in sharing as well, for SpiderMonkey builds, to get into the full details on that one.
Yeah, and I also understand that Javi doesn't yet support components, although that's something they've had their eye on. So that would help us also share different components that help do some of this work as well. So there's many different, I guess, touch points for collaboration across all of these different things. You mentioned a lot of different standards, and I'll be honest, I haven't been in the web space in a really long time, so I know that you have been doing some work with the TC39. Is that, I hope I didn't forget a letter there. Is that, did I even say the acronym correctly?
Yeah, no, that's it.
Okay,
it's all
great.
the letters. 22. Yeah, so I've been involved in TC39 for working on some of the modules proposals recently, and in particular, getting the source phase imports proposal to stage 3 recently was one of the things that we've been working on there. And this is kind of a proposal that allows you to load WebAssembly using so that when you are using JavaScript and WebAssembly together in an application, you typically fetch the WebAssembly with the fetch API. You resolve the WebAssembly with the URL API. So you have a URL global. You will check it as a relative path using the import.method.url API. And you will then instantiate it with the WebAssembly API. And that's like 4 specs across like 3 different standards bodies that you're going through. And this kind of gets back to that WinterCG thing that you've got all these different standards that are expected. So just like getting a JavaScript environment to a place where it can run WebAssembly, you now need to support 4 different specifications in a way that like a library expects to be able to load it. And so that was like, well, can't we just have a first class way? And what we do, we have the ESM integration, just import WebAssembly, and it would be much nicer. And the problem with that is that with WebAssembly, you don't typically assume that all of the WebAssembly module imports are going to be URLs. They usually need to be passed in explicitly. They need to be set up properly. And so the direct ESM integration wasn't always sufficient. And so what we came up with was a new spec that kind of aligned across the entire JavaScript virtualization story as well, which was a new spec for source phase imports, where you actually, instead of importing the fully executed module, you import the WebAssembly.module object before you've even linked it, but still through the import system. And that way you don't rely on all these other spec bodies to just get that WebAssembly. You can kind of just import it. And then with JavaScript, it'll also be able to support JavaScript virtualizations in future. So that was source phase imports. And I share the link in the chat if people are interested in reading up more about it.
Yeah, that would be really helpful. Thank you. I don't even know where to start for that one. So I really appreciate it.
Yeah.
Yeah, you've maybe heard on the internet where people are always like, what's harder, front end or back end? I'm solely in the camp of front end is way more complex than what I have to deal with when I build services. So I'm going to drop this in the chat. I do see that we actually have another question, and it is, what would a network version of this, I'm assuming this in this case is around WASI-Virt and virtualization techniques, and are these techniques portable? And I think we should also talk through in your answer about the difference between WASI Preview 2 and WASI Preview 3 and the lack of native async that's there today.
Yeah, that's a really good point. Yeah, I mean, the benefit of this, well, as you say, what remind me, what were you calling the general model of WebAssembly composition? What was the term that you
I call it WASI fills. What do you think? Do you like
WASI
that?
fills. WASI, I can get behind it. I like WASI fills. So yeah, when you have these WASI imports, you can, anything that provides that import can be used as the adapter. So, but you can then sort of in turn have imports that reinterpret it. So you can kind of map between different representations, and so in theory you could go from like WASI FS to like some kind of generic API, which is just like get path and set path or something, and then you could go from there to like anything that can handle like a get and a set string or something, or bytes or something on a path. And so you could then kind of branch out and have like all these different environments. And as you say, async is a big question there, because if you want to do network and IO and things like that, and that's still coming. At the moment, we're still very much on sync APIs for these things. But yeah, that's the sort of potential future where we could have all these different adapters that, if you want to map a file system to a cloud storage or something like that, it could be kind of interesting.
Yeah, right now, and we actually have a little bit more details on this from the last community stream where Pat Hickey gave a demo of support for streams inside WASM Time, one of the things he's been working towards. And one of the details that he showed is that there's now like basically a table that Wasmtime has for managing these pullables, which are these things that let us have essentially callbacks for async behavior. And so that orchestration is now happening within at a higher level, at the WebAssembly runtime level versus natively within components and intra components. And I believe that influenced a lot of your design behind WASI-Vert. Is that right?
Yeah, so the current design is very much built on top of the primitives around streams and the ability to define the different steps in the streaming process. And then also we don't, by default, put everything into memory all at once. We actually use passive memory segments so that you can individually load files into memory. So if you have large files, they're not all just put into memory at the same time. And so the whole thing has support for integrating streams and pullables in a way that would be able to support iterative. And in fact, it does support it all the way down. The only thing we're missing is the sort of async ticks between things to be able to support multiple things happening in parallel.
Great. Thank you. Thank you so much for digging into well, WASI-Vert, a little bit on some JavaScript land that really still out of my depth. But I think we've hit a lot of different interesting spots, and you've made some good call outs for places where we want feedback and good places to contribute. In your README, you kind of enumerated, it was like, okay, so I started with these two, right? And there's several other WASI APIs that would be interesting to virtualize. And so if folks are excited about contributing, I guess the best place to start is to jump in on that project, file issues, get feedback, make contributions. I would also say that you're on Zulip, right? In the Bytecode Alliance Zulip. So that's another good place to reach out and chat. Are there other good places for folks to get on and start contributing here?
Yeah, I mean the Vert project is, the hope for it is that it can be a collaboration as much as possible, and it can be a wide project where people bring their own use cases to it. And I'd love to see that. The setup that we have right now is just kind of very much an MVP, and it would be lovely to see if anyone wants to dive in and flesh it out further, or take it further, or take the different use cases. It would be cool to see what people achieve with it. Zulip is a good place to reach most of the Bytecode Alliance folks. A lot of the component model discussions happen on there, and a lot of the maintainers are available to help with any questions. So that's probably the best port of call. Otherwise, GitHub issues. I mean, with new projects, I always say it's better to post issues than not, because activity and seeing people interested in a project means everything. I know a lot of maintainers say don't post bugs and make sure you post in the right place, but personally, I think it's great to see that people are interested in using things, and even if they're stupid questions, it's great to get some level of insight into what people are interested in and interested in achieving with these kinds of things. So yeah, hope to see people on GitHub as always.
I love it. That's so great. While I have you here, since you're the person behind JCO, the JavaScript component tooling, and Componentize.js, are there any updates there that you think are worth highlighting, perhaps happened over the past month or two? I forget the last time you gave a demo of that on the stream. 3 months ago now, maybe? Anything to call out there?
Yeah, the projects are still moving along, and the JavaScript story for components is there's a lot to it, and it's a lot of work, and the component model is it's moving at quite a fast pace at the moment. So we're kind of just tracking all the latest updates across as the component model kind of converges. And this year there's been some incredible progress with where the base sort of primitives are, and so we're up on the latest, and the Componentize.js project I think is going to be the one that's going to have the most sort of interesting future work coming on it. At the moment, we just recently have added support for importing all the WASI APIs in JavaScript. So you can actually like import like the WASI primitives into JavaScript, like environment and FS and things like that, and use them directly from JavaScript. And I haven't really popularized that much, so it's worth calling out that effectively you can write a JavaScript app that reads a file, but it's using just WASI file system. And in the thing you could add to that is you could say, well, actually, now that you've got those primitives in JavaScript, you can just import them. You could write a layer that like recreates the Node.js APIs on top of that, and or you could have layers for any other JS environment. So getting to the level where we can meet the JS developers with the APIs that they're using, that's the long tail on the JS stuff, which gets really interesting. Where we want to go with that, and do you want to virtualize a Node.js app or not? I don't know, but it's interesting. It would be interesting to hear what people think. The Jaker project is more just sort of generic JavaScript tooling, making JavaScript, taking components and running them in JavaScript applications. And that's pretty much at a stable position right now. We're just working and fleshing out the support for resources in the component model. Yeah, other than that, it's if you haven't heard about it, it's a project that basically just has a transpile command, so you can install it as a JS developer npm install Bytecode Alliance Jaco, and you get access to this transpile command, which will take a component and turn it into a JavaScript and core WebAssembly that will run in any JavaScript environment, and has a bunch of utilities as well. So yeah, it's fairly stable at this point for the most part.
That's awesome. I think at this point, I'm going to stop grilling you, but anybody online, please send in your questions, and I'll keep asking them to Guy. But together, I figure we could talk through some of the cool things that are happening across the broader Bytecode Alliance community. So one thing I want to call out is that we now have an updated roadmap post that walks through a lot of things, including some of the, a lot of the work that Guy's been working on. I helped contribute to this, but honestly, so many people's fingerprints are on this, from David Bryant, Liam Randall. I should give the biggest shout out to Liam. Has been working to get everybody's feedback incorporated, and wrote really the initial version of this based off of me jibber jabbering about it. And so I think that this is a really great article to describe, what is coming, what we're actively working on right now. A lot of the language tooling, I have this kind of brief because I have the opportunity to talk to Guy, and I think this stuff here, each one of these bullets inside this post really warrants their own articles going through them. And if I did that, I think this would be a real essay. But if you want to listen to the original jibber jabber that generated this post, that's here. But I think we're just reading through this is probably enough detail for most folks, and I hope it's very helpful. We're also really open to feedback for the things that folks need to know, the things that they want to bring to their organizations, and more like transparency in any way. I think trying to highlight all of the different work streams on one like really simple diagram is a real challenge, but we were able to do it. So I'm feeling really great about that, and that was just released really today. So check it out and let me know what you think. The other exciting thing that's happening is that we are announcing a Componentize the World event that is going to be adjacent to WASMCon. There are details here on the bytecodealliance.org under news for this thread. And if you want to check it out, you click this link and it'll take you over to the Eventbrite page to sign up. I don't believe you need to sign up if you're planning on joining virtually, but if you want to be there in person, do make sure you reserve your spot. I'm really excited about this event, and Guy Bedford here is going to chair the JavaScript ecosystem side of this. So the idea is that We are so close right now to being finished with our work on WASI Preview 2 for the component model and the WASI side of things. And it would be really great for the ecosystem to have an opportunity to onboard, give feedback while everything here is in initial draft state, so that we can make sure we incorporate that before trying to, move forward with the standard and stamp this for a level of stability that folks can now start building on top of. And for me, I've got this list of basically Rust projects that I really want to support components and have that as one of the outputs of those projects. So I plan on hacking away and adding a bunch of different things to the upstream and making pull requests. And one of the key reasons why I think folks should be interested in this event is folks like Guy Bedford are going to be here at the executive briefing center here and at the Microsoft office in Redmond, Washington, and they'll be available for you to talk to them and learn and collaborate. And it's just a really great opportunity to onboard into this ecosystem.
Yeah,
And
I
so,
really
yeah, go
appreciate
ahead.
the chance to be able to have a community event where we're able to kind of see what feedback there is, how people are using things, what they want to see, what use cases they want to see, and that kind of feedback at this stage of the process is just so valuable to us. It's one thing having everything on GitHub, but it's another actually meeting people who are interested in using the component model and hearing about what they want to achieve with it and how we can help them get there. Huge. So yeah, I look forward to that.
Yeah, Kyle posted in the comments that we should do a carpool from the WASMCon venue. So that brings me to, hey, what's WASMCon? Well, it's coming up. So it is a Linux Foundation event, and they've been great collaborators with the Bytecode Alliance Foundation, setting us up with a co-located event for the Componentize the World event. WASMCon itself is September 6th and 7th. The Bytecode Alliance event is on the 8th. And so this is going to be in Bellevue, Washington, so like 20 minutes away from our colo. And it's going to be, I think, a really exciting event. We're going to have, we already have a ton of amazing speakers here on the schedule. I believe we're adding a few more, maybe up to like 10 at least. So I think once those come through, I can't wait to start pubbing things on social media and stuff, because in a lot of ways it's sort of really we've hit this point now, I feel, in the ecosystem where I can look at any technology stack and find a new use case of WASM that I didn't know about. I've been geeking out about WASM forever, and just seeing how people are taking it and making real awesome things just blows me away every time. So I can't wait to go to this event, and I hope everybody else has opportunity to go if they want to. So I'm going to stop sharing on that. I think I've hit all of the things that I wanted to hit. Is there any other questions online before we wrap up the stream? And before I'll stall for like 1 minute before we do that. So Guy, is there anything that you're hoping to see people hack on at the Componentize the World event?
That's a great question, and I guess the hope is to get answers to that. I mean, already what we've seen people come up with in terms of how they've been using tools like jQuery and Componentize.js is great. I mean, users have already run with it and helped flesh out a whole bunch of APIs and get things running in the browser and created sort of cross-functional workflows. Yeah, there's so many directions that this work can go in, and it's just like it reached this kind of point where there's like all of these different sort of vistas are open, and as someone working on the sort of enabling stuff, it's difficult to know what to prioritize because there's just so much that is possible. So just seeing what you know what is what people want to take out of it, and trying to support that as much as possible is my hope. But I'm super excited about virtualization. Is actually I found it really an interesting space, and like the idea that you could like virtualize different JS environments and things like that. And I'm still keen to see more work on driving that, and winter CG stuff and things like that. I'd love to see more collaboration on.
Cool. I think on that, we'll end this, but thank you so much for joining me, and I had a blast. So, see you